Good morning, everyone. Welcome to your new standard. Today we are going to do Algebra chapter 1 set. Okay, so first we'll understand what is a set. So, set is nothing but the collection of a well defined object is called a set. Okay, some properties are there of the set. First, the object in the set are distinct. Whatever the elements are there in the set, they are different. Each object in a set is called an element or member of the set. The following are some examples. First is what? Set of the days in a week. All days are different, correct? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Set of the month in a year, we have 12 different months. Then set of the student of your class. Each student is different. Okay, in color, in height, in appearance, everyone are different. Now, how to write sets? So sets are usually denoted by the capital alphabets A, B, C, etc. up to Z, and the elements of the sets are denoted by the small alphabets A, B, C and etc. So here set A is equal to A, E, I, O, U. So the capital alphabets represent the name of the set and all the small alphabets represent the elements of set A. If any object is a member of set A, then they are written as like this: A, then that mathematical operator and capital A. Okay, so here small a represent, it is the element of set A. Capital A represent set A. So what will read this? A is an element of set A, or we can say A belongs to set A. On the other hand, if an object B is not a member of set A, then we'll write B, then that mathematical operator and A. So it represents that B is not the element of set A, and we'll read it as B is not an element of set A, or we can say B does not belong to set A. Now the next is what? Representation of a set. So set are represented by using two methods named as listing method, which is also called as roster form, and second is rule method, which is called as set builder form. Now what is listing method? In this method, the elements are listed. Okay, name itself suggests what is listing method. It is listed. When we are going to a DMart, we are making the list of things. So that is called as listing method. Or tabulated. The elements are separated by what? Commas, and they are enclosed within the two braces. The order in which the elements are written or listed does not matter. We don't require any order. We can write in any order. This method is generally used when the elements are few and all the elements are known to us. We can use this method when elements are very less and all elements are known to us. Example number 1, the set A of all positive even integers less than 10. So what are the positive even integer less than 10? We are knowing that all 2, 4, 6 and 8. So the answer of A is what? A is what? A is equal to, inside the bracket, what? 2, 4, 6, 8. Example number 2. The set B of the letters in the word arithmetic. So set B is nothing but the collection of the letters in the word arithmetic. So what will come? B is equal to. Now which letters are used to form the word arithmetic? So first letter is what? A. Second R. Third I, fourth T, fifth H, sixth M, seventh E. Then next is I, but we can't repeat because we earlier read that the element should be distinct. It should not repeat. So we can't write I again. So what we'll write next? C. Okay. So these are the elements of set B. Repetition is not allowed. So the second method is rule method. In this method, the set is described by the common property of its elements. Second, this method is generally used when the number of elements in the set is large and there is a rule or property to determine the elements of the set. Example number 1, E is equal to 11, 12, 13, 14, 15, or we can say set E is equal to 11, 12, 13, 14 and 15. So here the elements are what? Natural numbers from 11 to 15. So how we'll write this in rule method? Set E is equal to X. That straight line or slanting line is called as such that. So what we'll read? X such that X belongs to natural number where X is greater than 10 and less than 16. So we have to write the natural numbers which are greater than 10 and less than 16. What are they? 11, 12, 13, 14 and 15. Getting all? Next is what? Set G is equal to 1, 8, 27, 64, 125. Can you guess which kind of number they are? They are what? They are perfect cube. First is cube of 1, second is cube of 2, third cube of 3, fourth cube of 4 and fifth is cube of 5. So what we'll write? Set G is equal to X such that X is equal to n cube where this small n represent number. Okay, so n cube where n belongs to natural number and n is less than equal to 5. So natural number less than equal to 5, what are they? 1, 2, 3, 4 and 5. Now before going to the practice set, we should know the types of numbers. This is very important. Okay, and you are knowing what types of numbers are there. Just we revise once. First is what? Natural number, which is represented by the capital alphabet N. Okay, they are also called as positive integers or counting numbers. Okay, so you are knowing what are the counting numbers? They are begin from 1. So what will come? 1, 2, 3, 4, 5 and so on. Second is what? Whole number. What are the whole numbers? Before that, whole numbers are represented by the alphabet W. Okay, if we'll add 0 to natural number, so it forms what? Whole number. So this is the set of natural number plus 0. That is what? 0, 1, 2, 3 and so on. Integers. Integers are nothing but the collection of positive, negative and 0. Okay, this is a set of all whole numbers plus all the negative numbers, or we can say opposites of the natural numbers. That is what? -1, -2, 0, +1, +2. All the numbers forms what? Integers. They are represented by the alphabet I. Now the rational numbers are what? This is all the fractions where the top, or we can say the numerator, and bottom, which is what? Denominator numbers are integers. Integers means what? 0, positive and negative numbers. But what? The denominator, that is what? Bottom, cannot be 0. But the numerator can be. Okay, denominator cannot be 0, but numerator can be 0. Okay, real numbers, which is represented by the alphabet R, also called what? measuring numbers or measurement numbers. This includes all numbers that can be written as a decimal. This includes fractions written in the decimal form. Example what? 0.5, 0.75 and so on. Now we'll begin with practice set 1.1. First question, write the following set in roster form. Okay, or listing method. So in this first question is what? Set of even numbers. Okay, you all are aware of what are even numbers. We can say which are divisible by 2 or we can say multiple of 2. So the answer is what? 2, 4, 6, 8. As we can't count the even numbers, so it will go on and on. So what we'll write? 2, 4, 6, 8, dot dot dot. Okay, it means what? It will go on and on. Unlimited we can say. Second question, set of even prime numbers from 1 to 50. Okay, set of even prime numbers from 1 to 50. So we want to find the number which is even as well as prime between 1 to 50. So there is only one even prime number, that is 2. So the answer is what? 2. Now next question is set of negative integers. So what are the negative integers? It begins from -1, -2, -3 and so on. It will not stop. It will go on and on. Uncountable, unlimited we can say. Next question, fourth one, letters in the word complement. Earlier we did in example mathematics. The same way we'll do here also. Complement. It is formed with the help of the letter. First is what? C. Second O. Then what? M. P. L. E. Again M came, but we can't write M. As we wrote once, so we can't repeat it. Okay. Then again E we will not write. Next is what? N and T. In between comma will come. Getting on? Next question, set of prime numbers from 1 to 20. So do you know what are prime numbers? Okay, prime numbers are such number which are divisible by 1 and by itself are called as prime numbers. And before that, one more thing, 1 is neither a prime nor a composite. 1 is neither a prime nor a composite. So excluding 1, remaining will check whether they are prime number or not. So first prime number is what? 2. Second is 3. 4 is not a prime number because it can be divided by 1, 4 as well as 2. So it is a composite number. It is not a prime number. Next we'll take what? 5. It is a prime number because it can be divided by only 2 numbers, that is 1 and by itself only. If we will take 6, 6 is not a prime number, it is a composite number because it can be divided by 1, 2, 3 and by itself, that is 6. So it is not a prime number, it is a composite number. Next is what? 7, it is a prime number. 8 is not a prime number. 9 is also not a prime number. It is a composite number because it can be divided by 1, 3 and 9. Okay. Then 10 is also not a prime number. 11 is a prime number. 12 is not a prime number. 13 is a prime number. Getting on? So answer is what? 2, 3, 5, 7, 11, 13, 17 and 19. Now question number 2, write the following set using rule method, or we can say set builder form. So the first question is what in this? Set A is equal to 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. So by seeing this number we can say they all are the perfect square. First is the square of 1, second 2, third 3, fourth 4, fifth 5. Okay. So what we'll write this one? Set A is equal to x such that x is equal to n square. where n belongs to natural number and n is smaller than equal to 10. So we'll get our answer. Second, set B is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So we can say these all are the day of a week. So what we'll write? B is equal to Z such that Z is a day of a week. Now the next question number 3, set C is equal to S comma M comma I comma L comma E. The answer is what? Set C is equal to Y such that Y is a letter in the word smile.